Alright, let's look at 31. You got p of x equals x to the third minus x to the second minus 6x. You can factor an x out, and then these two factor, and set each one of them equal to 0, and you get your three x-intercepts. Let x equal 0, and you find your y-intercept, which is 0, 0, 0. And by the way, this makes sense. If you've got 0, 0 as an x-intercept, you're going to get 0, 0 as a y-intercept. Always. Now the end behavior, this thing's degree 3, and a is positive 1. So a is greater than 0, positive. Degree is 3, so it's going to behave just like x cubed, up to the right and down to the left, which is what it ends up doing. Now we plot 1, 2, 3 points, these 3 points, and we know it shoots down here, and we know it shoots up here. And all of these zeros are multiplicity 1, because this is to the first power, first power, first power. So we know it's going to pass through. So we know it's going to come up like this, got to pass through, come back down, got to pass through, go back up, got to pass through. But we don't know how far down and how far up. So it'd be good to know what's happening at minus 1, positive 1, and maybe positive 3, positive 4. That's where I found these points here. I didn't use all of them. I didn't want to graph minus 4, minus 56. That's off the field, off the graph. So I only went from minus 20 to positive 25. So I plotted all of these except for the first one. And that's what it looks like. Now, 34. Degree 3, a is negative, so your end behavior is going to go up to the left and down to the right. The opposite of x cubed. Okay, you factor out a negative x, you factor this, set each one equal to 0, and you get these three guys here, which give you 0, 0. They give you 1/2, 0. And negative 1, 0. Okay, then you let y equal 0 and you get 0, 0. So we have 0, 0, 1/2, 0, and minus 1, 0. So all these other points I graphed just to see what was happening, especially at minus 1/2 and positive 1/2, to see how high and how low it goes. So then I connected the dots. I knew it was going to pass through each one of these because my multiplicity was odd. 1, 1, and 1 is the exponent. So I knew it was going to pass through. I just didn't know how high or how low it goes. But by plotting a few more points, you find that out. 35. Degree 4, a is positive, so it's going to look like x squared. Something like that. You factor out an x squared, factor what's left, set each one equal to 0, and you get 0, 1, and 2. So 0, 0, 1, 0, 2, 0. I noticed your y-intercept is also 0, 0. Remember I said if your x-intercept is 0, 0, your y-intercept will be 0, 0. So now we have these 3 points here, but we also know at 0 it bounces. Remember we said x equals 0 for x squared, so it's degree 2, even, it bounces. Odd to the first power, it's going to pass through. So it's going to bounce on this one and pass through on these two. Okay, so I plotted a few more points like minus 1, positive 1/2, positive 1.5, and so on. And I got the feeling of how high and how low this went. And I pieced it all together. 36. Degree 5, a is 1, so it's going to look like x cubed. And behavior shoots down to the left and up to the right. Factor out an x cubed, factor what's left, set each one equal to 0, and you get 0, minus 3, and 3. Okay. And I didn't know what was happening in the middle, so I checked minus 2 and minus 1, as well as 1 and 2. Gave me a better feel for what this thing is doing. And I just plotted my points. 37. Well, you got 4 terms here, so I thought factor by grouping. Factor something out of the first 2, factor something out of the second 2, and then they both of these bunches have an x plus 1 you can factor out, leaving you x squared minus 1. Now you've done that, this is the difference of squares. You can factor to x plus 1, x minus 1. And now you've got x is minus 1 or x is positive 1, so minus 1, positive 1. Okay, and notice at minus 1 it's going to bounce. And at minus 1 it bounces. At positive 1 it's going to pass through. Okay, the y-intercept is 0, negative 1. So we got 1, 2, 3 points here. We definitely need a lot more than what's going on here, so I checked minus 1/2, positive 1/2, positive 2, negative 2, negative 3. And I plotted my points there. 38. Okay, you got degree 3. A is positive 1, so it's going to look like x cubed. Like that. You factor out something out of the first 2, factor out something out of the second 2, and then factor that big item out of each one. So you do factor by grouping. And then this part factors to the difference of squares, so now you've got 3 different things here. Okay, each one gives you a different 0 of minus 3, minus 2, and 2. You've got a y-intercept of 0, negative 12. So we know we have this point, and this one down here. And we know that all 3 of these have multiplicity 1, degree 1, degree 1, degree 1. So each one is going to pass through. Well, we know that it goes down to the left forever, so it's got to come up, pass through, come back down, pass through, come back through the y-intercept, come back up, pass through, and end up on the far right going up forever, just like the end behavior says. Now the only thing we don't know is how far low or high it goes, so you might want to check minus 2.5, minus 1, positive 1/2, 1, and even, I think I checked minus 4. Some of these guys were too big, like minus 5, negative 42, that's too high to worry about, or too low to worry about. Number 40, I'll give you this guy. And again, these 4 guys you can factor by grouping. Inside this larger parentheses it's squared. It's kind of a weird problem. So you factor a x cubed out of the first 2, you factor a minus 8 out of the second 2, and they both have an x plus 2, 2x plus 3, and the other part is x cubed minus 8. Remember, they're both squared. Okay? Now, 2x plus 3, when you set it equal to 0 in factor, you get minus 3/2. Okay, x cubed minus 8, that's x cubed minus 2 cubed. That is the difference of cubes. Now right here is your difference of cubes formulas. You might want to write that down. A cubed minus b cubed is a minus b, a squared plus ab plus b squared. A cubed plus b cubed is a plus b, a squared minus ab plus b squared. Now the way to remember these is the terms are always the same. It's always ab, a squared, ab, b squared, b squared. The only thing you have to remember other than that is your signs. So minus is minus plus plus, and plus is plus minus plus. They all start with the same sign that they have on the left, but the plus alternates, and the minus just switches once. Okay, so you can factor this guy down to x minus 2 and x squared plus 2x plus 4. Now if you try and factor that or do quadratic formula, you will get no real solution. So the only 0 you get out of this is 2, and you get your minus 3/2 here. Okay, but remember it's squared, so each one of those is squared, so that's x minus 2 has multiplicity 2, and 2x plus 3 is 3/2, minus 3/2. This one minus 3, it bounces, right? And at positive 2, it's not multiplicity 2, it's multiplicity 1. That's why it passes through. And you also have a y-intercept of 72. And I picked a few more points in the middle, in between, to give me a nice smooth curve. 45, they ask you to take two graphs and graph them on the same screen with a small graph of minus 10 to 10 in each direction, and then minus 100 to 100, and see how it affects it. Okay, so you've got, they both are pretty close together, but they have a bit of a curve to them. But then when you change it to 100, the curve is gone, and these guys are almost right on top of each other. Now 46, when you look at minus 10 to 10 in each direction, it looks like this. But then if you change it to minus 100 to 100, it starts to look like the same thing. They're both starting to curve in the same places. 47, these guys are x to the fourth, but they're quite different. Okay? But then when you stretch it to minus 100 to 100, they start to look like the exact same thing. And now 51, they ask you to find the x and y intercepts and the local extrema and the domain and range. So you find the x-intercepts, setting equal to 0. Y-intercept is 0, 0. Actually, y-intercept is 0, 0. Your maximum is 2, 4. Your maximum is 2, 4, and your domain is minus infinity to infinity and minus infinity to 4. They want you to look at it on your calculator screen so you can see what that does.